In this video lecture, we will work through some problems using z-scores and probability. Here is the best way to find a probability from the unit normal table. Step 1, sketch the distribution showing the mean and standard deviation. Step 2, sketch the score in question, being sure to place it in the correct side of the mean and roughly the correct distance from the mean. Step 3, read the problem again to see if you need the probability of getting a score greater than, or less than, or between two scores. Shade this area on your sketch. Step 4, transform the X score into a Z score. Step 5, use the correct column to find the probability in the unit normal table. So here's an example. Suppose we have a normal distribution of IQ scores with a population mean mu equal to 100 and population standard deviation sigma equal to 15. What is the probability of having an IQ score greater than 120? So step 1, sketch the distribution. So here's a normal curve, approximately in the middle, kind of, is mean mu, which is equal to 100, right? So here's mean mu of 100, and a standard deviation of 15. So let's go ahead and put these in here, 115 and 130, right? So this is 115 is one standard deviation from the mean. 130 is two standard deviations away from the mean. And 120 is going to be somewhere about there, give or take. Okay? So this is step 1, which is sketching the distribution showing the mean and standard deviation. Step 2, right, we just sketch the score. And step 3 is read the problem again to see if you need the probability of getting a score greater than, less than, or between the scores. So our problem is asking for greater than 120. So that means we're looking for this. Let's go ahead and sketch this out. We're looking for this area, right? And this is the tail. And remember, this is the body, right? So we're looking for an area in the tail, okay? So step 4, now that we have a visual, right? Step 4, now we need to transform that X score of 120 into a Z score. So remember, we're looking for the probability that X is greater than 120. And in order to transform this, whoops, so let's do this. Z is equal to X minus mu over sigma. So X is 120 minus mu, which is 100, divided by sigma, which is equal to 15. So this gives us 20 divided by 15, which gives us 1.3333 in perpetuity. So our Z that we're looking for, or we're actually looking for the probability of Z greater than 1.33. And remember that in the unit normal table, we're given z's to the 100th, right? So we go ahead and round this to 1.33 so that we can take a look at the probability in the unit normal table. All right, so now let's go ahead and pull up our unit normal table. Now remember, we're looking for the proportion in the smaller section, right? The smaller section, which is the tail right here. So we're going to be looking in column C, right? In our unit normal table. So let's go ahead and scroll. We start at Z, a Z-score of 0. This is 0.25 here. So we need to find that Z-score of 1.33. And it's going to be in column C. And here is 1.33. Remember, this is column A, this is column B, and there's column C. So our area, our probability for a Z-score of 1.33 is equal to 0.0918, which is right here. Okay, so let's go back to our Word document and let's go ahead and put that in here. 0.0918, right? And so the probability of someone having an IQ score greater than 120 is 0.0918, or the percentage, right, of someone having an IQ score greater than 120 is 9%, or approximately 9%, or 9.18%. Okay, so there we go. We just found our very first probability or area under the curve. Yay! Awesome! So let's look at another example. Again, suppose we have a normal distribution of IQ scores with population mean mu equal to 100, right? And population standard deviation sigma equal to 15. What is the probability of having an IQ score less than 95, right? So again, sketch this out. I always recommend sketching this out. So here's 100. So now 95 is less than 100. We're going to be working with the left side of the distribution, right? So here's, let's go ahead and put 85 here, right? That's one standard deviation away from the mean, which is 100. So 95 is going to be about right here. So this is 95. And we're looking for IQ scores less than 95. So again, we're looking for the tail, and again, this is the body, right? So we're looking for the probability of X less than 95, right? And so again, we're going to standardize. We're going to go ahead and transform this X into a Z-score, right? So X is 95 minus 100 over 15, right? Remember, it's X minus mu divided by sigma. So this is equal to negative 5 over 15. And it is negative because we are on the left side of the distribution, right? And so our Z here is negative 0.3333 in perpetuity. So we're looking for the probability that Z is less than negative 0.33. We round to the hundredths, right? Okay. So now we go back. We need to go back to our table. And let's go back up. And again, we're still looking for the tail. And now we're looking for 0.33. And it doesn't matter. Remember, we talked about how the Z distribution, when we transform scores, this is a normal distribution. They're symmetric, so what happens on one side is the same thing that happens on the other side. So it doesn't matter when you're looking up a Z-score, whether you're looking up for a negative or a positive, whatever happens in the positive side, it's going to be the same thing that happens on the negative side. So we're looking at 0.33 in the tail, and our probability is 0.3707, right? Okay. So let's go back, 0.3707. So the probability of having an IQ score less than 95 is 0.3707, right? So the percentage of having the percentage of individuals having an IQ score less than 95 would be approximately 37%, right? Excellent. There's problem number 2.